What is the Gaia hypothesis? In the 1970s, a mind-blowing scientific concept proposed by British chemist James Lovelock and microbiologist Lynn Margulis suggested a radical idea. What if the Earth functions like a giant living organism? Named after the ancient Greek goddess of nature, this theory argues that all living things interact with rocks, oceans, and the atmosphere to form one massive, self-regulating system. Instead of life just passively adapting to its environment, the Gaia hypothesis proposes that life actively shapes and controls it, acting like the planet's built-in biological thermostat. For example, when greenhouse gases trap too much heat, microscopic ocean algae and vast forests absorb carbon dioxide to help cool the Earth back down. Algae even release chemical compounds into the air that seed bright clouds, reflecting sunlight straight back into space. Beyond temperature, living organisms help regulate ocean salinity and keep atmospheric oxygen levels stable enough for complex life to thrive. Skeptics point out that Earth doesn't have a central brain coordinating these efforts, but mathematical models like Lovelock's Daisy World demonstrate how natural selection and biological feedback loops can automatically stabilize a planet's climate. Ultimately, this theory suggests our world isn't just a dead rock floating through space with life on it. It offers a compelling framework for viewing Earth as a deeply connected, self-regulating system where microbes, plants, and oceans continuously interact to keep the planet habitably balanced.